So the next bit is about boosting pledgeable income, and we're going to look at multiple projects. So the first part is going to be about diversification, essentially doing two projects side by side. And then we'll go on in the video thereafter at sequential projects, so doing one project first and then doing a second project after that. So we saw that only if your pledgeable income from a project is sufficient to cover the investment, to cover the I minus A that the outsiders are giving, then are required to put down. Only in that case investment can be financed. So we also found that there's an inefficiency there, because even though a project might be positive NPV, if it doesn't meet this pledgeability or this participation constraint, if you wish, the project will not be undertaken. So there's a loss there in efficiency. And the question then is, so how can we increase this pledgeable income, right? So are there ways in which we can sort of devise projects or design projects such that we can circumvent some of these inefficiencies? So diversification will be the first one, and as I just mentioned, sequential projects or longer-term relationships in general might be second ones. And for diversification, I refer you to the book, Tirol, to chapter 4.2. So have a look at first at the lecture, and then you might want to look at how Tirol describes this in his book. So the idea here is, suppose now that instead of one project, there's actually two projects which are very similar, so actually almost the same. So both require an upfront investment of I, and there's moral hazard on each of these projects. So for both, the entrepreneur needs to put in some effort, and if they do, we have a probability of success PH, but if they don't, we have a lower probability of success, only PL, but then there will be this additional B, which were the private benefits for the entrepreneur. So this is basically the two copies of the fixed investment model that we looked at before. So let's assume that these projects are independent. So the success probability does not depend on the success of the other project. So these two projects have the same success probabilities, but if you learn that one of these projects was successful, that doesn't really tell you anything about the other projects. So we're going to make this assumption. And just to scale things, and in order to be able to compare the results with our original results for the single fixed investment, let's just assume, or let's call the assets that the entrepreneur has 2A. So there's two projects, they require 2 times I, so each project requires an investment I, and the entrepreneur has assets 2 times A. And what we want to do, of course, is look at diversification, but we want to compare it with a benchmark, which is just separate financing. So the entrepreneur could just treat these two projects as separate, go to the capital market as separate instances, and then we know, well, if this A is big enough for each of these projects, then of course the entrepreneur can do these projects, get financing for these projects, as long as A is bigger than what we call bar A. So in other words, as long as the inequality that you see on the slide here is satisfied, then each of these projects will be carried out, and there's actually no inefficiency, no problem. But what happens if this is not satisfied? So there might only be assets, there might only be money to carry out one of these projects if done separately. Now the question is, of course, can this entrepreneur do better than that? Can they sort of somehow find a way to carry out both of these projects? And what we are going to look at here as a solution is essentially joint project financing. So we're going to sort of put together these two projects side by side and ask for financing for both of them together. And the reason why we want to do this as an entrepreneur is that we can use cross-pledging. So cross-pledging basically says here, if this project is successful, if project number 1 basically is successful, then I'm still going to give all the returns from this project, the complete R, to you, funder, if the other project is not also successful. So this is cross-pledging. I'm going to use the income from the first project, which might be successful, and put this down as collateral for the second project. So if that's not successful, I just forgo that the whole part of this income from the first project and use that to make sure that the investors are actually breaking even. So what that essentially means is that the reward scheme that's now being considered for the entrepreneur is that the only way in which the entrepreneur is going to get any payment is if both projects succeed, not if just a single project succeeds. So in generality, you might have an outcome for the entrepreneur that says, well, you get a certain amount of money, R0, if all projects fail. Well, we can imagine, that's going to be 0, right? Failure all around, there is no money. So R0 is 0, no problem. But also, we have to define, or we can define an outcome or payment to the entrepreneur if one of the two projects succeeds and the other one fails. We call that, in the general contract, that might be, would call that R1. And we have to define, what does the entrepreneur get if both projects succeed, and we call that R2. So that's what we define these things to be. And what we're now going to assume, we are not only going to set R0 equal to 0, so if no project succeeds, the entrepreneur gets nothing. But even if one project succeeds and the other one fails, then also the income for the entrepreneur, R1, is also 0 in that case. And that's different, of course, from what happens if you carry out these two projects separately, because now for each separate project, if this separate project succeeds, you would get your due, your RB from that project. In this case, if just one project succeeds, R1 is going to be 0, and only if both projects succeed, then there will be a payment, and that we'll call R2, which is going to be positive. And you can imagine that doing this, setting this funding up in this way, is going to maximize incentives. You really want to work hard on both projects if you know that you need both of them to succeed for you to be paid off, to get your money. And that's going to help us. So we have to again, with this, in this situation, we have to again work out incentive compatibility conditions. And now there turn out to be two incentive compatibility conditions, or two inequalities that we need to satisfy. One says, well, we have to prefer putting in effort in both projects instead of no project. And the second is, well, we also have to prefer as entrepreneurs to be putting effort into both projects rather than in a single project. So this will be two conditions, and what we're going to do is sort of analyze these two different conditions and see what they amount to. But so it's on the slides, but let me do this on the paper. So we're going to look at two incentive compatibility conditions. So the first condition, incentive compatibility condition for the borrower number 1, says, well, we need to make sure that this borrower, the entrepreneur, is going to prefer working on both projects rather than shirking, being lazy on both projects, but getting a B for each of these projects. So what does that amount to? Well, if I work on both projects, the probability of success on both these projects is going to be pH squared, right? So remember, these two projects were independent, statistically independent. So the total probability of both projects succeeding when there is effort will be the square of these product of these two pHs, so pH squared. So that's probability of success on two projects. And in that case, the agreement here is you get some R2. So our assignment is basically figure out how large this R2 needs to be at least. So this is what you get if you're the entrepreneur. If you work on both projects, and we want to compare this with what you get if you do not work on both projects. So if I shirk, if I put in low effort on both these projects, then I might still be lucky with probability PL squared and both projects might succeed and I get my R2. That's of course lower because PL for each project is lower than PH for each project. But of course the upside here is that in that case I get B on each of these projects, these outside private benefits. So I get 2B in total. So this is the first incentive compatibility condition, and we can actually simplify this a little bit by bringing this first term here to the left-hand side. So we get PH squared minus PL squared times this R2 that we want to identify should be bigger than 2B. And if you now remember that PH squared minus PL squared is actually PH plus PL times PH minus PL. That's this quadratic identity that I'm sure you know. Then we can actually divide this through, and what you find that is that R2 needs to be bigger than, let me write it this way, 2 divided by PH plus PL times B divided by PH minus PL. So using the quadratic identity that we have over there. So this is the first one way of phrasing the first incentive compatibility condition. Okay, so that's one incentive compatibility. Well, I promise you to have two incentive compatibility conditions. So the second one is, let's call that IC2. It says, well, we want, again, the entrepreneur to benefit from putting in effort on both projects, succeeding with probability PH squared and then getting this R2 that was agreed upon. And that has to be preferred by the entrepreneur to working on one project and being lazy, putting in low effort on the other project. So what would then be the outcome under that counterfactual? If you work on one project, that project will succeed with PH. If you are lazy, put in low effort on the other project, that one will succeed still, but with a lower probability, PL. In that case, I would still get my R2 if I'm still lucky enough that this both projects still get realized. But because I was lazy on this single project, I also get the single B, these private benefits from this particular project. So can we sort of make this again a bit, can we rewrite this a bit? Well, R2 times PH times PH minus PL, so that results from bringing this term to that term and then putting one of the PHs, factoring out one of the PHs, putting it outside the brackets, is bigger than B. Or in other words, R2 needs to be bigger than B over PH minus PL, but now multiplied by 1 over PH. Okay, so we have two conditions, and basically this is of course in our previous notation 1 over PH B over delta P. Okay, the same here, this is 2 over PH plus PL times B over delta P. Delta P was this difference between the two probabilities PH minus PL. Okay, so I have two conditions, and so R2 needs to be big enough both for this condition to hold and for this condition to hold. Otherwise, this entrepreneur will say, well, for this amount of money, I'm going to shirk at least on one project, or perhaps even on two projects. So can we say something about these two conditions? And perhaps actually we can identify whether one of these two conditions is perhaps a bit stronger than the other one, so that if that holds, then the other one will hold for sure. So have a look at this and see whether you can see which of these conditions is more difficult to hold. So you might pause the video for a bit. Okay, so now let's assume you've done this, and you might have concluded that pH plus PL divided by 2, that's the average of the two P's, right? So this is 1 divided by the average of the pH and PL. This factor over here is 1 divided by pH, which is the higher of pH and PL. Of course, the average of pH and PL is lower than pH, right? It's in between pH and PL actually. So if the if this it's not the average, but the 1 over the average, as 1 over pH, you can sort of deduce that the expression we have over here must be bigger, or will be bigger, than the expression that we have over here. So that means that if R2 is bigger than this expression, so the first incentive compatibility condition holds, well then for sure also the second incentive compatibility will hold. So we actually only need to focus on this first incentive compatibility condition over here in this form, and then we are bound to get the other one for free essentially. So this will be the one that's going to matter. So that tells us immediately what's the minimum that we need to get as entrepreneurs in order to put in this effort. So the minimum R2 that we need for incentive compatibility is exactly equal to this amount, is 2 divided by pH plus PL times B over delta P. And now we can go further with our normal procedure basically of solving also for the participation constraint, because now we know what the pledgeable income is. So how much do we need to pay in expectation to the entrepreneur? Well, if both projects are successful, the entrepreneur gets the least, the minimum that the entrepreneur will get is this amount, but they only get this if both projects are successful. So the amount that at least we have to promise to the entrepreneur is this one. So it's pH squared. Let me just call it 2pH squared B divided by pH plus PL delta P. That's the amount that we need to promise at least to the entrepreneur. So what remains, what can we pledge to outsiders? Well, the total rents of this project, which is 2PHR, right? Minus what we need to promise to the entrepreneur, at least. So minus this amount, 2pH squared B over pH plus PL delta P. This is going to be the pledgeable income. So this is what we can promise to outsiders, to the outside investors. And now the participation constraint says, well, these outside investors are only going to invest in this project if this pledgeable income over here is going to be sufficient to make them break even. So the participation constraint now is for the lenders. Let me take a 2 outside of the brackets because you see 2 over here and the 2 over here, and write it like this: pH times R minus pH divided by pH plus PL times pH B over delta P. And that needs to be bigger for this project to be financeable than what we are asking these investors to put in, which is I minus A for each project. So 2 times I minus A. So this is going to be the participation constraint for the lenders. The total payoff of the project to PHR minus what we need to leave at least the minimum to the entrepreneur for them to put in the effort, which was this amount. That should be at least as big as what they put in. So the expected amount should be at least large enough to allow these investors to break even. So this is the participation constraint. So from that we can actually work out what the minimum value for A is that we require, again, so the A bar, and we call for this example now A double bar because we want to compare it to the A bar that we had before. Well, the A bar, let's get rid of the 2's to cancel out the 2's in order to figure out what the minimum amount of assets A double bar is for making this project financeable. Well, if you rewrite this a bit, you'll find it's going to be equal to I minus BH times R minus BH plus LB over delta P. So this is the minimum amount of assets that the entrepreneur needs to fund, to be able to fund both these projects in this side-by-side financing method. And what we want to compare this to is our benchmark. Our benchmark, remember, was this separate financing. And if you remember from the previous model, benchmark was I minus BH times R minus P over delta P. Can we say something about this? Well, of course, pH divided by pH plus PL, that's smaller than 1, right? It's something divided by not something bigger. So since this factor is actually smaller than 1, so if you work that out, the A double bar is going to be lower than the A bar. So the result of this is going to be A double bar is going to be lower than A bar. So what we can conclude from this is the amount of assets that the entrepreneur needs in order to finance both projects when funded as a joint operation, so in a single firm essentially, is a bit lower than what they would need if they would fund each of these projects separately. So it might occur that given the amount of A that this entrepreneur has, they are not able to fund both projects separately, but the A might be big enough, bigger than A double bar, such that they can fund this jointly. So why can they fund this jointly? Because they have decided to change the payout to getting only paid out if there's success on both projects, and that's a way to make it cheaper to give the incentives or to guarantee the incentives that the entrepreneur is actually going to put in the effort on both these projects. So let's see how this works in the slides. Let's go back to the slide. So we were here. So we had this first incentive compatibility condition. The entrepreneur needs to be better off working on both projects rather than being lazy on both projects, gives us one incentive compatibility condition. But the second incentive compatibility condition, which says, well, the entrepreneur also needs to prefer to put in effort in both projects instead of only one. Second condition, and we figured out, well, the second condition is actually weaker than the first, so we need to focus only on the first one, and then we get the second condition for free. So check this yourself again. And what we can, using that first incentive compatibility, which is going to be the important one, we find out, well, then what's the minimum amount that we need to promise to the entrepreneur to make sure that this is going to hold? And next step, what does it mean that we need to pay in expectation at the minimum to this entrepreneur. You can compare this actually to the so these will be the agency rents, so the minimum rents that we need to leave to the agent, to the entrepreneur, in order to put in the effort. And you can already see here that those agency rents are a little bit lower than the agency rents upon separate financing. And then we can, using this minimum amount, we can actually figure out, so what's the pledgeable income from this project? So how much can we then promise? What remains to be promised at most to the outside investors? And is that sufficient for these outside investors to actually break even and therefore to participate into this contract? So that gives us the participation constraint. And from that participation constraint, we can figure out what's then the expression for the least amount of assets, a double bar, that this entrepreneur needs to get this project financed. And by comparing them with the separate financing benchmark from our previous model, we find out, it might be the case that separate financing is not doable. So now we have inefficiency if you are limited to just separate financing. But if we manage to bundle these two projects in a package and use this cross-pledging, only paying out something to the entrepreneur if both projects succeed in this case, then we might be able to actually still finance both projects and get rid of this inefficiency. So basically what happened here is we create some value because we succeed here in carrying out this both these positive NPV projects. How did we do this? By decreasing the minimum amount of assets, this A bar, to a double bar, a lower value, so that indeed in this new setup, actually, the investor is convinced that the entrepreneur still has the incentives due to this cross-pledging to work on both projects. So a crucial assumption, I should say, is that these two projects are uncorrelated. So remember, that was the assumption that we made. So the probability of success of both projects is going to be pH squared times R. So that reflects that the probability of success for both projects is uncorrelated. And in fact, in the tutorial, we are going to look at what happens if that's not the case. Another caveat here, so another assumption, is that we basically made no assumption on that this entrepreneur would do worse by doing both these projects. So we do assume here that the entrepreneur is actually able to do both these projects, to put effort in both these projects, which assumes that they are within their competency, right? So this entrepreneur is really doing these projects because they can do them, not because they look so nice or give them so much power, basically, an empire building rationale behind these diversification strategies. And so also the entrepreneur does not suffer basically from limited attention, for instance. So they are actually able to carry out these two diverse projects on a good basis, which might be sort of two assumptions that in reality turn out to be important as well. Okay, so that was diversification, doing two projects in parallel. So the next bit will be about doing two projects, one after the other, so sequentially. So let's have a look at that now.